Good morning, students. Today, before going to the class, we will be discussing something in the daily situation. Then we will be going towards our class. So imagine that there is a heavy rain out there, and the time is early in the morning, and your mom is calling you to get up and go to study. So what in that situation, what would be your mind or your body telling you? Will there is a tendency to stay a bit longer in bed rather than laying the bed and going to the studies? Isn't it? Yeah. So today's class is actually related with this kind of hesitation or this kind of inability of laying the bed. Okay. Now, Newton's first law and law of inertia is the interdependency between Newton's first law and the law of inertia. That's what we are going to do now. And there is a connection between the situation that I have settled. Okay. Actually, the law of inertia is formulated by Galileo Galilei, who was a scientist, lived just before Newton, and Newton has actually taken his studies of Galileo for Newton's study. So the basis of Newton's study lies under the study of the Galileo Galilei. So Galileo Galilei's study is the basis of Newton's study. Okay, so there will be a connection since both are related explicitly. So first law we already discussed. Anyway, we will recall in short while, or we will recall it with few words. Then we will discuss the law of inertia and how it is connected. And the first law is also called law of inertia. Okay, so the first law and law of inertia are same, but though it explains the same context, the perspectives, the views are different. That's only the difference. So now we are again recalling the first law. If net external force is 0, the body can be either at rest or it may move with constant velocity. In either cases, the acceleration is 0. If the body remains at rest, then the acceleration is 0. If the body is continuous with constant velocity also, acceleration is 0. So body continues in rest or moves with constant velocity when external force is 0. Now, imagine a cycle which is at rest. So, Newton's telling it will continue to be at rest till the external force is 0. And if the cycle is at rest, we can also tell that, or we can also assume that the cycle itself can't change the state of rest to state of motion. The cycle can't itself change the state of rest to state of motion. So this inability of cycle to change its state from rest to motion or to change its state of motion is called actually inertia. So inertia is the inability of a body to change its state by its own. For example, if a body is at rest, then it is having the inability to change the state of rest to state of motion by its own. The Newton is telling we need the external force, and here we are telling the body itself can't change the state of motion. Actually both are same. Newton is telling external force is needed to change the state. Here we are telling the body itself can't change the state. Isn't it? Both are same. but only the perspective is differs. So law of inertia, the inability of a body to change its state by its own is called law of inertia. And if you are looking at the state of state of motion, we actually talked about the increasing the speed, decreasing the speed, or changing the direction. So all these cases, when speed increases, there will be inability. The body itself can't increase the speed, or the body itself can't decrease the speed, or the body can't accept the change of direction. So every time when the speed changes, there is an inability in changing the speed by the body by its own. Okay, and there is an inability in the body to change its direction by its own. The body itself can't change the direction of motion while the body is moving. So in order to change the direction, what is needed? External force is needed. When the body changes its direction, what happens? Velocity changes. Velocity changes only when external force is acted. That is what Newton is telling. Here what we are telling, in the direction also there is an inability. So Galileo is talking about the inertia, we can regard it as the inability or the tendency to remain the state, the tendency of a body to remain its state of rest or state of uniform motion along a straight line is called inertia. So first we will talk about the inertia of rest. So inertia of rest, the inability to change the state of rest to state of motion by its own, by the body itself, is called inertia of rest. The inability of a body to change the state of rest by its own is called inertia of rest, or we can also say the tendency of a body to remain in its position of rest. The other way of talking the same is the tendency of a body to remain in its position of rest. If the body is at rest, then it will be remained at rest, or there will be a tendency of remaining to be at rest. Okay, that is the inertia of rest. Now inertia of motion. If a body is moving with constant velocity, then that body is having the tendency to continue with constant velocity. So if a body is moving with constant velocity, that particular body is having a tendency to continue with constant velocity. The inability of a body to change the state of uniform motion, to change the state of uniform motion along a straight line. Uniform motion along a straight line meaning velocity is constant. So if a body is moving with constant velocity, then there is an inability of that body, where the body can't change its state of uniform motion along a straight line by its own. That is actually inertia of motion. Now we are talking about the inertia of direction. Obviously, the body itself can't change the direction of motion by its own. The inability of a body to change its direction of motion by its own. The inability of a body to change its direction of motion by its own is called inertia of direction. So we have inertia of rest, inertia of motion, and inertia of direction. Now we will be recalling some daily situations. Then we will discuss the relationship between mass and inertia. So first we are talking some cases of inertia of rest. Listen, just assume that or imagine that you are boarded in a bus, and the bus was at rest, so you were also at rest, and the bus suddenly starts from rest to motion. So bus actually changes its state of rest to state of motion by applying external force, the frictional force actually helps the bus to change the state of motion. Because of the friction only the bus could move forward. Okay, so external force is applied. What is the external force? Frictional force is the external force which helps the bus to move from rest to motion. And you were at rest before moving the bus. Both you and the bus are at rest. Now bus is moving and you are, just imagine you are standing in the bus. So your foot is, or your feet is in contact with the bus, and if you are imagining very carefully, you can see that there is a contact between your feet and the floor of the bus, so that when the bus moves there will be friction between your feet and the floor of the bus, or your feet and with the bus. So along with the bus your feet moves. Okay, but there is an inability of the rest of your body. That rest of your body is still in a tendency of to be at rest. Your feet is moving forward, whereas your rest of your body is static. Then what happens? When your feet is moving forward and rest of your body is static, meaning that you will be leaned backward and you will fall backward, and this is because of the inertia of rest. Your body was at rest and your body wants to continue at rest. That's why you have fallen backward. So when because of inertia of rest you will fall backward. And the same way, now imagine the bus is moving in a straight road with constant speed. Okay, so if the bus moving with constant speed in the straight road, that is constant velocity, suddenly the driver applied the brake so that the bus reduces its speed. Now the speed is changing, that is also because of the external force, actually because of the friction. So bus is reducing its speed, whereas you are in a position of motion, you are in a condition of motion, or you are in a state of motion. So that what happens, your feet is again in contact with the floor of the bus. So when bus is stopping, your feet is going to stop, and rest of your body was in a condition of motion then rest of your body will move forward. Rest of your body, other than whatever remained other than your feet, is moving forward because you are in motion and your body wants to continue with motion. But because of the friction between the floor of the bus and the feet become static, so that your body is moving forward and feet is becoming static. You are leaning forward and you will fall forward. So that's why you are falling forward while the driver is applying the brake, and you will fall backward. The bus starts. The same happens while increasing the speed and decreasing the speed. So if the speed is decreased, you will fall forward. If the speed is increased, you will fall backward. This is because of inertia of motion and inertia of rest. Inertia of rest, you will fall backward. Inertia of motion, you will fall forward. Now inertia of direction. So before getting some real examples, I will tell you something which is more easy to understand. See, we are having a stone and you tied the stone with a rope, and you hold the rope in your hand and you just circulated it. So the stone is actually circulating. Okay, how you are circulating? While circulating, actually you are pulling the rope towards its center. So you are applying a force on the stone through the rope towards the center. That is how you are actually circulating the rope. And if you are all of a sudden, if you are loosen the grip from the rope, the stone will no longer continue in its circular motion. Rather, what will happen? So we can imagine that I am going to, this is my circle, okay? This is the direction of motion of the stone. So I am circulating in the anti-clockwise direction. This direction is actually anti-clockwise, and this one is clockwise. So if the body moves in the way, such a way that the hands of a clock moves, then that is clockwise. If it is opposite to the motion of the hands of the clock, that is anti-clockwise. So now I am imagining I was circulating the stone in the anti-clockwise direction. At that instant where I loosened the grip, the stone was in that position. Now the stone will be thrown in this direction, because the stone was circulating through the circle. You were pulling the stone all the time towards the center. That's why it was circulating, and when you loosen it, no external force is acting on it at that point of time. We are not talking about the pull of the earth, we are talking about the force that we applied. The force we applied is now zero, so that the body will move in this direction. So actually this was the direction of motion. The body is actually taken inside or slipped in this direction because of your continuous pull. Now there is no pull, so that the body moves tangent to the circle. This is actually called tangent to the circle. So the body is having to continue its direction of motion. The body actually does not want to continue in circular motion. Actually it wants to move in this direction, but all the time you are just pulling it. That's why it continued in the circular motion. Whenever it is free, it moves in its direction. So there is an inability of a body to change its direction of motion by its own. The inability of a body to change its direction of motion by its own is called the inertia of direction. Now imagine that you are traveling in a car, and the car is taking a left curve. So the car is actually taking a left curve, so that you may fall in the outer direction. So just like this. This is our curve actually, and this is our cells. So in this point, you may fall in this direction, outward direction. You may fall in this direction. Why you are falling in this direction? Actually, what happens here is, when you are sitting, there is a friction between the seat of the car and the conducting part of your body, that is your bottom side. So that your bottom side moves along with the car. The car is actually taking the rotation with the help of friction, and with the help of friction, your conducting part to the car also taking the same curve. But rest of your body is in this inertia of direction. That is, the rest of your body wants to continue in this direction. So rest of your body is moving in this direction, and your bottom side is moving in this direction, making you fall in the outer way. Okay, and the same is true for if you are making the curve in this direction, you will fall in this direction. Okay, so this is happening because of the inertia of direction. And there is so many cases are there. If you are considering the horse For example, if the horse and horseman, if the horse starts all of a sudden from rest to motion, the horseman will fall backward, and if the horse stops all of a sudden, the horseman will fall forward. And even before taking a long jump, the athlete run a certain distance, so that the athlete will be in a state of motion, so that the body will be having a tendency to be in motion, making the person to lift more distance. So in order to increase the distance of jump, the athlete is actually the person is actually running a certain distance. So these kinds of example you can see in your daily life where inertia happens. Now we will be talking about the last part of the lecture, that is how the inertia can be increased, or what is there anything that defines, or that is depending, that influences the inertia. Is there anything that influences inertia? Consider a cycle and a car. You want to speed up the cycle and the car. So for example, you are pushing the cycle as well as the car, so that you are imagining both increases its speed. So while increasing the speed, the change of state happens. So which will resist more to change its state, meaning which will be having more inability to change the state, either car or the cycle. Obviously it will be car. The car will be having more inability than the cycle. If you are giving certain force itself, the cycle will be accelerated with a high magnitude, but it will not be happened in the car. So car is having more inertia because the mass of the car is greater than that of cycle. So when mass increases, the inertia also increases, meaning that inertia is proportional to mass. Inertia depends upon mass, or we can also say mass of a body is the measure of its inertia. So inertia is measured by its mass. Inertia is regarded with its mass. And inertia is a sensation actually. We can't say we say the physical quantity and non-physical quantity. For example, if we can measure anything, if a quantity that can be measured accurately or that can be measured is known as physical quantity. For example, distance, displacement, or time, or length, area, surface area, volume, all these can be measured. So these are actually physical quantity. But inertia is a kind of sensation. I have beginning itself I told a life situation which we can relate it as there is a sensation that you want to be in your bed in the early morning, where the environment is forcing you to be at bed. The same is somewhat similar happens in these conditions also. That one is, for your curiosity only, I told that lying in the bed. Actually, you should not take it to while explaining the inertia. You should follow these kinds of wording rather than that one. Okay. Now, inherent property of material. Inertia is the inherent property of material, meaning that the inertia of the car or inertia of any body, that is not given by ourselves. That is having within the body. The body is having that property by virtue of it. So that property is not given by any external agent, but the property inertia is included or embodied within the body itself. That is why we will say inherent property of the material of the body. So we discussed the Newton's first law and law of inertia. Law of inertia and Newton's first law are the same, but viewing with different perspectives. Okay, I hope you understood the video. Thank you.